Hello, my name is Shane Brinkman Davis Delamore, and this is Code and Optimism, a show where we explore how to solve things faster with software. So today we're going to follow on the conversation we started last week, which is about the trouble with software is often not building the software. It's the fact that we're often solving the wrong problem. Nothing sucks more than building a huge chunk of software only to find that no one's going to use it. Trust me, I've done that way too much in my career. The thing here is, how do we figure out what the problem is that we should solve? And I call that the essential problem. So today's topic is talking about how do you find the essential problem. This is still the second in a multi-part series. We're going to be talking about the meta problem of software development, which really boils down to, it's not just that we want to solve problems faster with software. We actually want to solve problems that have the most impact, that have the most meaning, that have the most value. And to do that, it is really critical that we start by finding the essential problem. So I'm going to talk about three things today. I'm going to talk about why do essential problems matter. I'm going to talk about how do you know if your problem is essential, or what is an essential problem. And I'm going to talk about how you actually can find your essential problem if you've got sort of a start on it. So let's start at the top there. So why do essential problems matter? And really it's going to come down to focus. First of all, they're just personal focus. If you can figure out what your essential problem is, it allows you to, as you're sitting down to keyboard, as you're sitting down doing the work of translating this vision into reality, it allows you to stay on track towards your goals. And the more precise and more essential your problem is, we're going to talk a little bit more about all those traits in a moment, the more your ability is going to be able to make all those choices throughout your day as you're designing things, as you're building software that are going to align with your goal. If you don't have a clear sense of that understanding, you're going to make suboptimal decisions, because in the creative space of software, we are making decisions 10, 20, 30, 50, 100 times a day that slightly nudge the course of our product down the road. Next is team focus. And this is super critical to have a problem statement that everybody really buys into and really understands. Nothing is going to create more team alignment than having a really clear problem that's really well defined. Now, the solutions may not be well defined, but if the problem is well defined, then the team can really get behind and go the same direction. Because another way that's going to be a disaster for a software product is if each person is going a slightly different direction. And so instead of your boat going straight towards the most direct path to your success, it's sort of has a lot of jiggle and it's bouncing around to the sides and it's not staying clear on course. At this point, I'll sort of throw in, I guess let's go to the third thing. The third focus is long-term focus. So that's the last thing that can be a problem without the problem of not having a clear problem is to have really meaningful and large impact on the world, usually it's going to take a long time to build up to that point. And if you do not stay the course, if you're wobbling and weaving all along the way, you're going to have much less chance of achieving the distance towards that long-term big impact. Now, to be clear, we do not know really where that endpoint is. It's really impossible to guess it along the way. You're going to be doing small experiments. You're going to be adjusting course. You're going to be learning along the way. But if you can define the essential problem, even if you don't actually know where it is on the map, you can't quite define where it is on the map, at least where the solution is on the map, the problem statement will tell you how to correct course with each learning you have. You learned a little something, the problem statement says, well, given that information, you have to go left in order to get closer to where you're going. And at this point, I'm just going to use SpaceX as an example. So SpaceX's problem is really well honed. Their problem is Earth is a single point of failure for life as we know it. Full stop. Now, they don't quite speak of it that way, but if you listen to Elon Musk talk about it, it'd be pretty clear this is what they're talking about, right? They're talking about they want to have a backup for Earth on Mars. So Their goal is to get a permanent colony established on Mars, an independent colony that can exist whether or not Earth continues to exist on Mars, right? That ends up being their strategy. But the problem is Earth is a single point of failure. And thinking about Earth as a single point of failure is a little bit of a mind-blowing concept because it's so big for people. But we understand single points of failure in computing. Like that's something we deal with all the time for redundancy. Like we know that any system that you need to stay online, that you need to actually not fail, the only way to achieve it is redundancy. Because the only thing that is certain is that anything that exists will fail eventually. It just will. And so redundancy allows you to have two systems, and yes, they will both fail eventually, but one can fail and the other one can keep going because you have redundancy. And the combined system, of course, will eventually fail, but you can get basically exponential multiplicative, thank you, multiplicative feedback in terms of, well, if this one fails only one time in 10 and this one fails only one time in 10, then the combined system in a simple model only fails one time in 100. And so you can get this sort of glorious feedback loop by having redundancy. And that's all SpaceX is saying. Earth is a single point of failure for life. If Earth got wiped out by some big disaster, life as we know it would end. So that's their problem. Now, that's a big, crazy problem to solve. But now every single choice along their way has guided them towards building Starship, which is they realize, well, if Earth is a single point of failure, we need redundancy. Where are we going to put redundancy? Well, we could possibly put it in orbit around Earth, but that does make it a lot of things that could happen to Earth that could hurt Earth could possibly hurt things that are in orbit around Earth too, like asteroids and other such things. And also it's reasonable to question how big of a structure we'd have to put in orbit that could then be itself self-sustaining. And so they've recently decided to say, well, let's actually put that structure on Mars instead. And either way, they came to the conclusion, well, we've got to cut the cost of getting mass to orbit by several orders of magnitude because it's just going to take so much more mass to get into space than we've ever done before in order to achieve this goal. So then that leads them back to reusability. They did, booster reusability. The first ones to really do that seriously. And now they're working on the largest rocket ever that is fully reusable, which is all in this goal. I mean, those all sound cool, fancy things. Us people who love rockets love that. But the key thing is they're getting the cost down so that they can build a thing on Mars. Like everything lines up to that long-term strategy. And every choice down to the nuts and bolts on their machine is going to line with, does this help us get a backup for life on Mars? Full stop. That's how an essential problem can guide individual making progress without the day, can get a team to go all the same direction, and to, over the long period of time, stay on course. So at the end of the day, why does all this focus matter? It gets us to realizing the value faster. Without this, if personally you make sort of suboptimal choices throughout the day because you don't have a clear vision, those can be corrected later. That's fine. It can be done. If your team's not quite all aligned and you're wibble wobbling all over the place, that'll just slow you down, but you can still get there. If you don't have long-term focus and your whole team as a cluster is kind of going left and right, you can still eventually get there, but it's going to take longer. That's where the focus comes in. Get to value fastest. The better your focus, the faster you get to value. And that's why all this stuff matters. So, second thing, what is an essential problem? And how do you know that you've got to the essential problem? I've been thinking about another concept for a long time, which is the essential solution. It's kind of where I started this essential thinking is, given a problem, how do you know that your solution is an essential solution? And I'm not going to go into that today. It's related, but it's a little different. But some things are similar between the two. And so I'm just going to give you a few descriptors and give you a little bit of color, but you're going to have to apply them to your problem to decide if they fit and to see if your own problem, because it's very subjective. But the first one that always comes to mind to me is timeless. A essential problem is timeless in the sense that maybe in a slightly different form, but in a very parallel form, it is relevant 100 years ago. It'll be irrelevant in 100 years from now. This Earth is a single point of failure for life. That's something we couldn't have solved 100 years ago, but it was a problem 100 years ago just as much as the problem now, right? That is an essential problem in this sort of timeless scale. And even once we have, another colony on Mars that's up and going and healthy, well, now we got 2 points. And we all know that in computing, again, if you want to have a high number of nines of uptime, you actually really don't want just dual redundancy. You want like triple redundancy, right? So that problem is going to apply for 1,000 years in the future or more. So that problem has a sense of timelessness. Now, again, SpaceX is kind of the biggest of the big problems. Your problem can be small and still have a certain set of timelessness. And the timelessness might be plus or minus 5 years. But you should look at how big your solution, how big your problem is now in terms of its time dimension relevance, and say, how can I make that 10 times more time dimension relevant? That will make it a more essential problem. Next, it's irreducible. And I think this is maybe one of the most critical ones, is that if you can take your problem and break off part of it and it is still relevant, that problem still makes sense even though you've broken off a part of it, then you have not gotten down to the essential problem. And I wish I had a great example off the top of my mind, but what you will notice is when you get down to an essential problem, you can't remove part of it without it becoming meaningless. So the problem, Earth is a single point of failure for life. Well, we could remove life from that problem. Well, Earth is a single point of failure. Oh, no, it isn't. Actually, there's thousands of planets out there. Like there's other planets. We don't know if they have life, but we know there's lots of other planets. So if we take Earth as a planet is a single point of failure, the problem becomes meaningless if we remove life. And if we remove the single point of failure aspect, we believe that there's life all over the universe. Well, we might say there's a single point of failure for humanity. And so that might tweak our problem a little bit, but that would be a good thing to do. That would make our problem a little bit more specific, and more specific is always better here. I don't know if it's always better, but it can be helpful here. So there's that sense of irreducibility that you can't slice off, and you just start with your problem, just remove words. Can you remove any word there and have it still be meaningful? Sometimes you might have to diagram it as concepts and say removing a concept and say, does the problem still make sense? But that's the sense of irreducibility. It's universal. I'm just going to drop that without jumping too much into it, but you can kind of see how that plays along these lines. This next one I think is interesting. It is, I use the term together, deeply valuable. I mean, of course, we want our problems to be about, if it gets solved, it's valuable, it's worthwhile, it does something. But deeply valuable means something a little bit extra. I'm not meaning deeply in the expletive sense or in the like super valuable. It's super valuable, it's ultra valuable. I don't mean that. I mean deeply in the sense that there's layers of value. And the example here is if your problem ends up driving you to a strategy that says make mass to orbit 10% cheaper. The question is, if you make mass to orbit 10% cheaper, is that valuable? Yes. If you make it then after that 10% cheaper again, is that still valuable? Yes. And then if you make it 10% cheaper again after that, is that still valuable? Yes. That's kind of a simple example, and obviously SpaceX needs to go for several orders of magnitude, not just 10%, but maybe it's 1 order of magnitude, 2 order of magnitude, 3 orders of magnitude. The point is that your problem leads you down a path of incremental and more deepening of value. And so it allows you to show value each step of the way, and it shows you a path towards consistently being able to increase your capabilities to go after this problem, that each level gives you more value. So that's what I mean by deeply valuable. It isn't just like I Boolean one thing done and there's not a whole lot more value to capture there. It is a path of continually more depth of value. And perhaps the last important thing is it answers the question of why do we care? At the end of the day, this essential problem needs to be something that you can put on a poster in front of everybody working on it, and they are excited to work on that problem. It's meaningful to them. They can see how it has impact on the world. It's motivational. It gets them excited. That's another aspect about a well-stated essential problem. All right, last thing we're going to talk about today is how do you find your essential problem? And we're not going to dive into all of these things right now, but I just started to gather some of the techniques that I have seen that I like. There are so many of them out there, and there's no one right answer. The one I'm playing around with a lot lately that I've always liked, but not until recently I've been able to use very effectively, is the 5 whys question of, and this about, all right, you state a problem, and then you say why. Why is that the problem? And then you state an answer to that, and then you say, why is that answer the problem? And you dive all the way down. Five whys comes from the sort of root cause analysis, which I think is similar to finding your essential problem, but it's a little bit different too. The root cause analysis is like, this part failed, why? And then you can explain that. And then you say, well, why did that happen? Then you explain that. And eventually you get to, like, what's the real thing that caused this cascade of failures? And that's great. And in a certain sense, finding your root problem that's a problem, right? That's a problem finding steps. But in this sense, I'm thinking about it more as a conceptual motivational problem than a specific narrow problem. This is an essential problem is very broad, which is why I said that sometimes specificity isn't actually what you're looking for. It does need to be specific. It's kind of specific and broad at the same time. It's specific in that everybody can kind of agree that you're going in the right direction, but it's broad in that there's many ways to address it. So that's the 5 whys. And another one that I've really liked is one of my all-time favorite TED Talks by Simon Sinek, which talks about why, how, what. And his key phrase from there is that people don't buy what you do, they buy why you do it. And his is really all about marketing, but really this applies to the essential problem analysis, which is that a problem is not a technology, it's not a method, it's not a strategy, it's a why statement. It's a why do we care? Why does it matter? Why is this valuable? And inevitably, we always end up, our first pass of these things usually is a what statement. And we need to back it out from what to how to why. And so I'm going to put a link to that video down below, Simon Sinek, if you haven't seen it. It's one of the most popular ones on there, but if you have not seen it, it is well worthwhile watching. Simon Sinek also has other great ones, so if you want to go down the rabbit hole, enjoy his other videos as well. But the why, how, what video in particular, I think is really motivating, and it's pretty short. It's a TED Talk. Next, SMART goals. None of these things are particularly secrets. You've probably heard some of these, but I think SMART goals are often not applied as often as they should be. SMART is specific, measurable, achievable, relevant, and time-bounded, which is more or less, all those together means it's a goal that can happen, right? But achievable is the third letter, which also means a goal that can happen. But really it's specific and measurable. And again, I saw there's sort of this duality of specific and non-specific with this essential problem question. Like you want it to be timeless, which kind of seems non-specific because it spreads over more time. But it's specific in that everybody can sort of agree on where the destination is. Measurable is really key in terms of how do you know that you're achieving that goal? Is it going to be clear? With the goal of having a sustainable colony on Mars, and there's a million ways you could design a sustainable colony on Mars. And arguably the sub-goal there is how do we do it as quickly as possible, right? Earth is a single point of failure. Again, our root goal guides us. Earth is our single point of failure. Why do we care? We want to get a backup before failure happens. So as quick as possible to the point of having a sustainable colony. And there's a certain point of how much you don't want to cut corners, because sustainable needs to mean a colony that can, in principle, grow, expand, and repopulate even if Earth is gone. And we can be wildly successful on its own. It can't be meagerly sustainable. It can't be sustainable in that sort of strict sense of it can keep 100 people alive for a long period of time, but it can't ever really grow, right? That's not what we would consider a colony that we want on Mars. We want a cars that not just sustainable, but thrivable, that can grow and succeed. Again, that is a great example of an essential problem because it gives us all this guidance in a simple statement. Time-bounded really just means that you'll know when you've achieved it. In this case, the time bound for this goal is as quick as possible, but is very clear when you've at least in principle achieved it. The last one I'll put out there, which is even more generic and almost more dumb, and everybody's heard of it, which is just ROI, return on investment. And it doesn't necessarily have to be a strict financial return, although most likely, no matter what we're doing, there is going to be a financial analysis that needs to be applied, because ultimately, what is money but an abstract representation of value? And that is a way for us to compare two different values to decide which one gets closest to achieving the goal that we have. And so there is always going to be a money trade-off involved, and we need to make good choices about running money trade-offs. So return on investment really just says, is the amount of value we're investing in this worth the amount of value we're getting out the end? Are we getting more value out of the end of this than the amount of value we're putting into it? Take money and put it on the side. Money is only an abstraction of value. It is not actually value itself. It's just an approximation of value. But ROI just applies in general to, it takes time and energy and effort. Ignore the money part of it. And at the end, we want to get more time, energy, and effort worth of value out the other end. So ROI. All right. Those are the three things I want to talk about today. Talking about finding your essential problem. Talked about why, what, and how. So why does it matter? The answer is focus, focus, focus. It keeps the whole enterprise of solving your problem on track. And why do we care about focus? Because it gets us to realizing the value faster. And maybe another way of putting that is it ups our chances of success. Every bit of additional focus you have ups your chances of success. It is the measure of how you up your chances of success. It's how you control your destiny is focus. And getting the right essential problem is key. What is an essential problem? Well, an essential problem is timeless, irreducible, universal, deeply valuable, which means it's layered, and ultimately answers the question, why do we care? Last, how do you find your essential problem? There's a lot of tools to help you do it. And again, if you tie it back to what I just said about what is an essential problem, you can use whatever tool sort of feels most natural to you to get around to it. I'd also argue it's worth using the tools that feel uncomfortable to you, because uncomfortably challenging your problem might get you outside of your loop thinking and get a fresh perspective. But some of the ones I've used, the 5 whys process, why, how, what from Simon Sinek, SMART goals, just basic ROI analysis. All those things can help you tune in your essential problem. So that's today's talk. I would love to hear from you. What are your thoughts? I would most love to know, what tools have you used to hone in and refine your problem, to compare apples and oranges and decide which one is the one you want to focus on. How do you do that thinking to make sure that you are solving the problem that has got the best chance of delivering the maximum value and has the best chance of success? 5 whys, how, why, how, what, SMART goals, ROI. I know that's just the tip of the iceberg. I would love to hear of other things. I'm sure I know of some of them that I've forgotten, and I'm sure I don't know of some of them, which is where you could be a hugely valuable resource to me and others by sharing your experience there. I would also love to hear other examples of essential problems or failures, projects that have failed because they did not define their essential problem. I love hearing those stories, so please share them below in the comments. And I will, I'll do what every YouTuber does. I don't do this too often, but I would love it if you would like and subscribe. It's a silly little game, but it pumps the algorithm and helps get this content out to other people. My goal here really is just to share these ideas. If it happens to lead some for success for me, that's great. I would love that. But really, I just want a place to get these ideas moving because I think they're important. And if you think they're important too, liking, subscribing, commenting, that helps YouTube know that other people might be interested in this as well. So once again, I will thank you for spending your valuable time with me. And remember, all problems, especially the essential ones, are solvable with enough knowledge.